Last time we also did an awful lot. Mean, simple average, the median, the middle observation, the mode. And then we did the absolute frequency distribution, the relative frequency distribution, and the cumulative frequency distribution. And today, the plan is tables and figures. Don't do this at home. Stupid things you can do with Excel and that you should never do. I will give a few examples. I will also show you that you are much smarter than the computer. Then we're going to do exponential growth. That's an important issue from the perspective of the environment. And then we're going to take a look at the exponentials and the logarithms. Now, if I'm well informed, you hate logarithms, right? So at the end, we're not going to do a lot of calculations with logarithms, but I simply want you to understand what it is. Right? There are one or two things that are really based on logarithms, but where we don't use it, and there it's helpful if you see how it works. Also because it's easy to make a logarithm in a graph, and people very often do it. And I will show you why this is the case. And then in the end we will talk about the exam and about the 3P. So 1P, 2P, 3P. Good to remember. That's what you have to do. In the Moodle, we have now a separate folder where all the presentations are also with the answers, right? So that you can see the detailed calculations over there. You can first take a look at the handout, the original handout, the PowerPoint. There you will see the exercise, then you can simply do the exercise and you can check it in the other folder. And I will put the final lecture there. And then all the lectures have been taped. We will provide you with YouTube channel kind of place where it's put. It's called ISS Media, and there will be something on lectures. And you can simply download it and take a look there. Okay? So, tables and figures. This is about tables and figures. The first thing that you should remember about tables and figures is not that they are there to annoy you, but to give some information. So you have to take a look at the table and at the figure and see what kind of information is there in these things, because people want to tell a story. Tables and figures can make the data immediately clear, because if you have to write down what is in the table, it will take you a page. Or when you want to write down what is in a figure, to do this really good, you will need at least a page. And even then, when I have a page with a lot of numbers, I often have to make a little table for myself so that I can understand the numbers. They also help you to see something directly. Something goes up, and then there is a down turn. We will see a few graphs which give you like an idea about this. So this is the things about why they are there in the articles that you read, and why I hope that you will also incorporate them in your research paper, because a research paper gets a better grade if it also contains graphs and tables. But then it needs to be sensible. And the most important thing is labeling. It should be completely clear what the graph is about, or the table. So we need the rows, the columns, the series. Clear and ambiguous. Remember that I showed you this graph of the frequency distribution. One bar was blue, one bar was red. We knew that one was female and the other male, but we didn't know which one. So that's not correct, that's not clear labeling. Second is, you should be able to understand the table on its own, and if it's in your research paper, then you should give a reference to the table. That's why we give them numbers, right? See table 1 or see figure 1. Don't use the table below, because you will be typing and then you will be cutting and pasting, and at some point in time the table will be somewhere else, right? It's not below but above, or it's on the next page. So it's understandable on its own. If you take a look at the graph, you should be able to understand what it is. And not have, you should not be having to read everything. And then it should contain all the information, the minimum amount of information that is needed to communicate this message. And that's the thing you really have to be aware. If you get a graph or a table, it is information and there is some sort of a message. And it's not a good table. It's an important table because it's about the topic that we discussed last year. It's deaths of children under 5. And then we have 5 countries. Botswana, Kenya was in the video, Mozambique, South Africa and Zimbabwe. Now why is this not a good table? Well, it has pros and cons. It looks like a table. Yes, sir? Why is it not a good table? You? No? Somebody else?
There are no references?
No male, female, no age are there.
Sorry, you first and you in 3 things, right?
And there is no male, female churches about children, no age.
There's some information which is not there. What you want there.
No reference, no table, no.
Okay, there's no reference, right? You?
Does it tell us what groups of diseases kill the children? For instance, if group A, they died out of measles,
Yeah.
it would be out of something else.
So we actually don't know what it is, right? We have to guess. Okay, so let's take a look what the table is about. And let's make it better. So this one is okay. Why is it okay? There's a number, it has a title. Now it tells me also what this is about. It's about children. You said I didn't know whether it's a boy or a girl, but now we know at least that it is boys and girls together, right? Here it says year of data collection. That's something we could have guessed, right? But now we know. So the previous table was bad because it did not give that information. And then it says these children can die from diseases that are communicable. That's what you can transfer between humans. See? It says here maternal, prenatal and nutritional. That can move between people. Then it's not non-communicable. That can be a disease like cancer, which is not communicable. You have the cancer, but nobody has to be afraid that he or she gets the cancer from you. Then there is injuries as a special category, and then there is a part which is quite big, right, over here. Not defined. So now I understand what the table is about. There's also one important other thing. Source. If you don't have the source with the table, it's simply plagiarism. But it's also bad science because people should be able to check whether you used the proper kind of data. But they should also be able to see that this is the original source. They should. You have a question, boys, girls, go to the source and see what is in the source. And I can tell you that if you take a look at it, you will find that there is a distinction by gender. But the table was collapsed in order to make it not too big. And if you collapse the table, you will lose information. Now, when I take a look at not defined, I think it's a very big category. Much bigger everywhere than injuries. So there must be a lot of stuff in there, right? Can be anything. Or we know that the people died, but not of one. Okay. And it is different from other, right? It says not defined. It says not written down. You can also see that the data were not collected at the same moment. They are about the same time. Why is that? Because it happens every 5 or so years. Because it's expensive, as you saw in the YouTube. The majority of the diseases, this kind of disease, it's always bigger than here. Right? So that could be the story that you want to tell. it's not the case that you can say it's more serious in Kenya than it is in Zimbabwe. Because I think Kenya is much larger than Zimbabwe. But I'm not sure, right? I would have to check this. Okay. Now, this is the same information. Exactly the same information. But now it's put in a figure. You can always make the choice. Right? When you present the data, whether you want to do it in a table or in a figure. One is not better than the other. It depends a little bit on what you find easy, but also how you want to convey the information. Now, if you use the figure, there's one thing that you can see directly. That's most people in Kenya, most children in Kenya, then South Africa, Zimbabwe, Mozambique, Botswana. Of course, you can also see it over here. But for me, it's more difficult to see this, right? To see that this is this one, plus this one, plus this one, plus this one. I need to make a total. What is the information that I also can see directly? Communicable diseases, largest part. At least I can see it here, 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 and here, and not over here. Now, if I want to say something about Botswana, then I should not use this figure. Why not? Because very difficult to see, right? So you lose the information on the topic if the topic is Botswana. This is an exercise, and you can do it with the graphs and the tables that are provided, but it is an exercise that you can always do. Right, so it's more like a checklist as well. The first question is, if you make the table, why do you put the table in? Why is it there? Because it's an element, it's part of your argumentation. What is the message that you really want to tell? Then you have to think about how you could reorganize the data. Could you do it in a different way? Do you need extra information? Right? Very good. Do you need extra calculations? Well, one of the things which is difficult about these big numbers is that it is difficult to see the shares. When I have the table over here, it's a good table, okay, but it is difficult to see what is the share of communicable diseases in Botswana, in Kenya, in Mozambique, in South Africa, or in Zimbabwe. And it might be relevant because there might be differences. And it may say something about the effectiveness of health policies in these countries. So, what I was thinking when I did the first and the last question was, can I calculate the shares? And then of course I have to do the percentages, right? So again the same information, and now we can see that in Kenya the share of these communicable diseases is much larger than in South Africa. So I did something with the data. I processed the data because I want to tell this message, right? Now, can we see something different? Something else? Yes, we can see Mozambique, very low number, but also a very large number not defined. So if I would make a comparison with Mozambique, I would know that the data are not that reliable because the disease was not recorded for everybody. Okay. Same graph, same data, but now in a graph. Blue, labeled communicable. You can see directly this one is larger than this one, is larger than this one, and this is the smallest one. Or if you want to take a look at not defined, this one is largest, then we have this one, almost the same, this and this. Okay. And now you can also see that sometimes there is a difference between a graph and a table, because I said almost the same. Now if I need to know the number exactly, oh, it is the same. It is not almost the same, it is the same, right? So if you want to give reference to a particular number, and it needs to be 9% or $1.2 or 365,000 people, then you can better use the table, if you need the exact number. But if you need to make a comparison, a rough comparison, use the fingers. I think we have the percentages. What is the information that we have lost? You wanted to ask a question? First the question, then my question.
But in the year, there is a difference in the duration of year 1996 and 2000.
Yeah.
But because in a year, situation changed a lot.
Yeah.
So every country has different year of surveys.
Yeah. It is, the world is imperfect, right? We cannot change it. So it's very difficult to make the comparison. So if this is about something which definitely happens in a specific year, for example, a change in the organization of healthcare, then you need to pay a lot of attention to what period you are using, before or after. But if there are not these big changes, then you can make a reasonable comparison, because typically if healthcare is bad, it is bad in every year. Now something different can happen. That, for example, if there is a specific disease, right, which spreads. Now, if this happens in 1996 and you don't have the data for 1996 for a country and you use the data of 1998, then there is of course also a problem. This is why for this kind of research it is very important to have the years. And that's why I also kept the information in the graph, right? Normally you wouldn't see it, but I think these are very important questions, so people should be able to check what we have been using. And you can see here, it gives a star, and it says, oh, where is the star? I lost the star somehow. Should be, I think, in the heading, but it says, in brackets, year of observation. Because brackets is a difficult word, I always write brackets in brackets, right? It helps to explain everything. Right? If I would say in italics, so that's like that, right? And it would be in italics. I always do, or in black, but it will be black. Helps people. What information was lost in the previous graph and table that we had in table 1 and the figure 1? Sorry? The actual figures. Very good. So, here we know the percentages, but we don't know how many people anymore. Now the question that you have to ask yourself is the question, is it bad? I don't know the answer. Right? Because the table that I showed you was helpful because it gave you percentages. And it depends on your research question what is good and what is bad. But I always have the source over here. And people can check. You can always go back to the source. This is the basic reason why we give the source. It's not because we are afraid of plagiarism, because you don't want to do plagiarism, right? That's not what we are afraid of. It is because people are then able to go back to the source. They are also able to use the same sort of data. Now, this machine is very dangerous. It can do tricks and it's unexpected. Let me show you one thing here. This is Excel and PowerPoint. You put in numbers and they do things for you. So I make a pie. It shows the percentage or the shares. I give equal weight. I make 3 parts. Each part is 100. 1/3 That's 33.3%. So this is a very clever machine. It can do the rounding. So it makes 33%, 33%, 33%. And then there's a problem, because it's not adding up to 100. So the machine has a rule. It makes it up, but they are equal. Right? Now take a look. 34, 33, 33. It adds up to 100, but it doesn't make sense. This is something what the machine does. Doesn't matter a lot, but it does it, right? So if you have a rounding problem in a graph, the machine will solve it for you, and it will give the 1% to the first number that is mentioned. So it makes 34. Now, of course, you can also cut the pieces again, right? So now I have 6 pieces, equal size. Take a look. 16, 16, it's 16.6%, right? So you have to round it up. 17, 17, 17, 17. Why is this 16? Because it's a wrong number, and the other one 17. Because 6 times 17, that's 102. 2 too many, right? 2 too much. So the machine goes the other way around. So I've shown you that if you have a diagram with percentages, and if the first one, if there is a rounding problem, the first one might be plus or minus 1%. And if this happens, it's very simple, right? So the machine is not always giving the right kind of answer. And the machine does more. Like, for example, when you give the machine numbers, it will automatically generate a graph. No thinking, right? So take a look over here. This looks like a very, very big decrease, right? And this is what the machine shows. Is it fair? This would be better. Now you can see that there is a change, but only a tiny change. Same numbers. This is where you don't say anything to the machine. And here you have to tell him the minimum should be 0. I think this is fair, this is unfair. Same numbers, it can be worse. This is bad, but if you hit the buttons, students love it, right? They love to make something different, not a boring bar graph. But here, this is boring. This is even more boring. Here I can see the numbers. I can see what is largest and what is smallest, right? But here it's impossible to see. It's actually impossible to see. You can't find it, right? And it can be more stupid. Other button. Now I can't even see the numbers, right? So this is a big danger of the machine. You can make it very beautiful. But if you want to be doing something with science, keep it boring. Keep it extremely boring. And simple. Label, make sure that the table can be understood on its own. And don't go for the fancy things. If people have fancy graphs, they have something to hide. Because if it's boring, then the story is often true. Now what's wrong with this graph? No label. No information what this is about. There's more wrong with the graph, right? There's more wrong with the graph. Take a look. It looks as if the biggest jump is here. See, from 1 to 8. But they've tricked you, because here on the axis you can see 1, 1, 2, 4, 16. So the biggest step is from here to there, from 4 to 16. Yes? It looks as if this is the biggest step, but that's from 0 to 8. And here I go from 4 to 60, so that's 12. This happens very often with graphs, and on purpose. Right? It's on purpose, because there are other things with these graphs. I will show it later on. Very useful ways of using the graph. But there is also a problem with these graphs. And that is that it looks as if something is very big. But it is not. Okay, we will come back to that shortly. So that was the first part, about how to show information. And now I'm going to do something which is more difficult, but it is also very important. It's about exponential growth. So, best to turn down the thing now, because first we are going to get, because it's a